lots of people coming in. Yep, everybody here? Okay, welcome to the meetup of Tiqets and PyLadies organized together here at the Tiqets headquarters on the 12th floor with a lovely view of Amsterdam. I'm Sietse van der Laan. I'm the tech team manager at Tiqets. I'm mostly doing the people management for the tech and product department, creating the teams, supporting the teams, enabling the teams, etc. So what does Tiqets do? This is a short introduction to Tiqets. Yes, PyLadies might want to do a word as well, and then we continue with the talks for today. What does Tiqets do? You can book tickets for attractions and entertainments online via the app, via your mobile. You receive the tickets via email, via SMS and the app. And of course, you can then show the tickets on your smartphone at the venue, and boom, you're in. We just make it easy. Offices all over the world. We're now officially in all the continents. Well, not Antarctica, but besides Antarctica, we're on all the continents. Most of the people are in Amsterdam. And you can see the setup of the other offices as well. It's already outdated. We have more offices than this. And this is how we grew. We started with a few guys in a small office, bunched together, building a tool, pivoting, coming to what Tiqets now is. And this was early last year, so we need to update this. We've already grown quite a bit. So how do we set up our product development teams? We call them focus teams, and they're focused on a specific part of our product. On the one hand, it's the consumer. On the other hand, is the venue, and within that specific focus teams. Usual team set up product owner, tech lead, backend, front-end, UX design, QA. And in 2020, we're growing more teams. Lovely animation. And of course, lots of vacancies, backend, front-end, DevOps, data engineers, data analysts to join the data team, as well as product owners, senior product owners, project managers, UX, and product specialists. Big list, but we're growing rapidly. Tech stack, if you're interested. Quite a lot. I hear one, wow. So that's Tiqets. Enjoy tonight. You see, there's more meetups coming up in the future. But yeah, the first talk goes to Yuri, and I'll give the microphone to her. Enjoy tonight.
Can you hear me? Yes. Okay. There. Thanks. Thanks everyone for being here. I was just looking at my name and I wrote down an accent because that's how you write it down in Spanish, but hey, you can do some data cleaning and remove it, okay? Yuri, Mejia, Miranda. Mejia. Okay, so thanks everybody for being here. I'm gonna be a storyteller today. Actually, oh, that way. Oh, it doesn't. Ah. Or we can also do this. No? It worked before. Okay, anyway, I am a data scientist here at Tiqets, but tonight I'm gonna try to be a storyteller. So we'll see how it goes, okay? A little bit about me. Yeah, sure. Okay, I am from Mexico. I speak Spanish, therefore my name is Mejia. Oh, here it is. I've been working at Tiqets for 1.5 years now. I work very closely with the marketing department, specifically with the PPC team. I'm gonna talk about it later. But before Tiqets, I actually did clinical trials. It was fun. We will give some new treatments to people, and then some of them will be driving a simulator and that kind of thing. So it was fun. My background is in mathematics. I did some probability theory. That's where I studied my PhD. So I'm going to talk a little bit about my trip. So I started in Mexico. I don't know who recognizes these landmarks. Yeah, I see some people, yeah, from Tiqets. Which one? These ones. Okay. Yeah, well, this is a very nice pyramid in Mexico City. Well, close to Mexico City, so I live very close by. Then I went to Vancouver to study mathematics. That is the Vancouver Aquarium. By the way, we are selling tickets for it. And that's the Rijksmuseum, as everybody knows, right? So I went from Mexico to Canada to Amsterdam, and I'm here at Tiqets. I also like playing board games. So recently, someone very close to me gave me that board game, which is called Teotihuacan, which is basically about those pyramids. It's very cool. So if someone wants to talk about it, please come and talk to me. I also like doing sports. I love doing running. Like, but wait, I should also say that I love Python and R, right? Okay. So this is me in a nutshell. And this is what I'm gonna talk about today. Actually, when I was making the presentation, I always had my bullet list here. And, oh, this is what I'm gonna talk about, blah, 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 the sections. But then I realized that I wanna tell you a story. And this is gonna be the story of building this building at Tiqets. So does anyone recognize this building? You know which one it is? Yeah, yeah, who said yes? Well, yeah, actually that is a view from this building. The Burj Khalifa, and where is it? In Dubai. What do you know about it? Why is it so cool? Ah, great. Still, yeah. Do you know the height? Oh, really? Oh, nice. I was gonna, okay. So does anyone know the height of this building? Oh, okay. Anyway, so when you think of the Burj Khalifa, actually the Burj Khalifa is 830 meters high. When you think of the Burj Khalifa, you look at this amazing building, like with amazing viewpoint. By the way, that's the 124 and 25th floor. But actually no one thinks about this one, right? So everybody thinks about this beautiful building, but no one really thinks about this. And actually the Burj Khalifa also started like this. So my talk is gonna be about basically two parts. The first part is gonna be about building the Burj Khalifa like one floor on top of each other. And the other one is gonna be a little bit about this picture. So actually building the foundations for the Burj Khalifa. Because right now that's what we are building at Tiqets. Okay, so who is familiar with machine learning? I think everyone, right? Oh God, I should have known this. Anyway, so I'm sure you recognize this pipeline. So exactly, so you start with some data, so you ingest it somehow, you prepare it, and then you divide your data set into training, testing, validation, you build your beautiful model, and then you do some predictions, right? So everybody's familiar with this. And usually, they always tell you about this part, right? And no one really talks about this part because this is a bit not so sexy as that one, right? Exactly, exactly. I want you in my team. Okay. You're hired. Okay, so, all right, as I said, it's gonna be two parts. So the first part is building the Burj Khalifa, you know, one floor on top of each other. So, and this is what I want to talk to you about it today. So when I was thinking about this talk, I was thinking, well, but I do data science, but how did I ever started doing object-oriented programming? Well, I actually started by using the objects themselves. And this is how, I don't know, I guess everybody's familiar with this. Yes, no? Is someone not familiar? Is everybody familiar? Okay, so who is familiar with all of these, like with scikit-learn and, oh, almost everyone. Great. Have you ever thought about why scikit-learn is everywhere? Well, let's say. So have you thought about it? Does anyone program with another language? Which language? R? And how is it? So can you make objects easily in R? Like, I haven't tried. Okay. Who else uses another programming language? Scala, okay. Java, yes. Yeah, okay, so as I mentioned, I'm also an R user. So actually, when I tried to do some classes in R, it was a bit more difficult than in Python. So this is how I started. Like, so first I started just using the objects, right? So I started using scikit-learn, I started using pandas, matplotlib, numpy, etc., etc. But then I started thinking, why is it that scikit-learn is everywhere? Like, why is it so good? And then I started thinking, I actually found this paper in which they actually analyzed the API of scikit-learn. And basically, what they talk about it is that, first of all, it's project-oriented, it's object-oriented, sorry. It has a very consistent API. So exactly, so it's very easy to interchange elements in your program. It's very well documented, actually. It has very nice examples, descriptions, and so on. It has a lot of the machine learning tasks that you need. And actually, there's a team of dedicated experts implementing these models. So it has many, many, many good things. Okay, so who is familiar with Google datasets? Some people, okay. Yeah, the thing is, because as I said, I'm working with marketing a lot, but unfortunately, I cannot share with you our marketing data. So I was looking for a nice data set related to marketing, and it's like, what can I do? So actually what I did, I went to Google datasets. So there is basically like Google, but for datasets. So just write down, for example, in this case, it was something like Google Analytics or Google Ads dataset. And then basically you get displayed many papers and also the datasets that are related with this paper. So that's actually quite cool. And that's how I found this Kaggle dataset. So is everybody familiar with Kaggle? Yes, yes. Who wants to share what it is? No one? So who is familiar with Kaggle? Okay, so apparently everyone. Okay, good. So well, I just have to say that Kaggle is this platform where you can, what companies actually can upload datasets and problems related to these datasets that hopefully you can solve with this. And the nice thing is that people not only, well, they try to solve it, you can even get some money, but also people share. It's very important, people share. So this is how I found this dataset. This dataset is about marketing campaign. This is this is for Facebook, actually. It's an anonymous organization, so we don't really know what it is about. It's a bit difficult because there are some questions there. For example, what you can see is that it has more than 1,000 observations. It has 11 variables. And for example, I was looking at these two in particular, impressions and spend, like the money that you're paying for it. For example, I didn't even know, is it euros, is it dollars? I don't really know. But anyway, this is a very nice data set to start with. Is everybody familiar with marketing? Ooh, a little bit. Who else? A little bit, a little bit, a little bit. Okay, good, because then I can teach you something today. Great. Okay, so when I started working here at Tiqets, I came from clinical trials. I was doing completely different things. So I got dumped into the marketing team, and I had to learn as fast as I could. So it's good that I'm a runner because I can be fast. Anyway, so many questions, they ask many questions, like what are our impressions, what is our cost, what is Bliss, what is that? But the very first thing I did, wait. I don't understand how your variables are related to each other. So let's just start simple, right? Let's just start very, very simple, because let's start just understanding the variables. Like, for example, they told me, okay, so how it works is if you pay the most, then in theory, you should get more customers. Is that true? So basically, this is what you pay, and this is the impressions of your ads in the social media, well, in Facebook in this case. So I started, okay, let's start there. Let's see if it's true. So I did some very easy Python, and then I saw this. I plotted this like for an exploratory analysis. So over here you see the cost, and here you see the impressions on the y-axis. And well, the first thing I saw is like, yeah, this is clearly a line, right? So I actually took and I drew the line myself. This should be the line, or more or less, right? But I don't know if this exactly. This was just like very intuitive. Like, so this is how basically you start always. Like, you start simple. You start actually questioning your data, writing down your hypotheses, testing them, and if it's true. Okay, so then I thought, okay, let's start simple. It seems like a linear regression would make the trick, right? So then indeed, so I started running a linear regression, and then exactly this is the beauty of scikit-learn. Like the steps are exactly, you have to prepare your data, you have to divide your data set into train, test, and then you train your model, and then you make predictions. And all you have to do here is basically, okay, if I want linear regression, I put it there where the arrow is there. And then if I want to make an instance of it, I just do it here where there's the regressor is. So if I want another model, all I have to do is to import another model there on the top and change here which one I am instantiating, right? So in this case, actually I thought, okay, well, linear regression is not that bad. It's actually this one. So is everybody familiar with this? Do you have questions? No questions. Okay, perfect. And I thought, okay, well, you can also go and, as I said, instead of having a linear regression, you can also go for a more complex model, like a random forest regressor, for example, and then basically do the same. Okay, so what would be the next steps? What are the next steps? So you're very familiar with this topic. So give me ideas. What would be the next steps? Ideas? Ah, good, exactly. So you need to compare the accuracy, right? You need to have like a metric to measure the performance of the models. What else do we need? What else can we do? Because we're building the Burj Khalifa, remember? More ideas? Yes, tell me. Uh-huh. Yes, okay. Yeah, you did the whole pipeline. Perfect, yeah, indeed. There are many things we can do, right? Exactly. We need to determine what are the metrics for performance. We need to actually evaluate our models. We have to tune some hyperparameters. We have to do some model selection. We have to interpret the results. Oh my God, we have to build a pipeline, and we have to automate the process, and so on and so on and so on. We're building the Burj Khalifa, see? So this is how I thought, oh my God, this is awesome. I want to do this for my job. This is what I want to do. But then, remember, this is building the Burj Khalifa. But actually, the Burj Khalifa didn't start here. It started there, right? So I don't know if you're familiar with this, but I call it the garbage principle, because in computer science, and also definitely in data sciences, garbage in, garbage out, right? So your model is only as good as your data is. So before you go and build this beautiful tower with this beautiful view, you need to make sure that your foundation is strong. And your foundation for a nice model is your data. So you have to do this. So Titze was just talking about our focus teams. We have the PPC automation team. That's my focus team right now. So we're sitting across the street. We are, I'm working with some developers and a data engineer and some marketeers now. So now what we are doing here at Tiqets, we're building the Burj Khalifa for the PPC team. And everything starts at the bottom, right? So we are doing right now, we're doing the data integration, data harmonization, and everything. And so I'm gonna talk a little bit about it. Is everybody familiar with PPC? Marketing, a little bit. Ah, great. This is what I'm gonna explain more. Okay, so let me explain how it works. So usually when you are planning your vacations and you said, oh, well, next week or next month, I'm going to the Keukenhof. What do? Well, you go to your favorite search engine, like, well, your favorite one. Most probably you're gonna type tickets Keukenhof, right? Or tickets for the Keukenhof, or Keukenhof, or how to go to the Keukenhof. Well, you choose your favorite search. Okay, so what happens behind the scenes is that all the companies like Tiqets and others like compete to each other, and then in an auction. So if you win the auction, well, if you are above in the auction, you are actually, you get to be shown here on the top display. I don't know if you have noticed that if you search for something, the first things are ads, usually for ads, and then it comes the organic search, right? So the thing about PPC is that the company, in this case Tiqets, is still not paying for this app. Tiqets is only gonna pay if you click on our app. If you click on our app, then we're gonna pay for it. Otherwise, no. So in this case, suppose that you click on our app and then you're going to land in that beautiful page of the Keukenhof. And then you continue with buying with those, okay? So exactly, one of the things that I learned is that the ads have three very basic elements, which is the headline, the display URL, and the description. These are like the three most basic elements, but they can actually have many things. So I've been working on optimizing these ads, but that's another story. So I'm going to take you a little bit deeper into PPC, because this is very important. So I think until here, everybody understands it and everybody knows this story. But then you get into this one. Aha. Okay, so this is what the marketeers see every day. So our ads they follow a structure. So there's an account on top of it, and then the accounts have campaigns, and then the campaigns have ad groups. An ad group is, you can think of it like a cell. Like it's the most, the simplest complete entity here. So an ad group is gonna have ads, keywords that get activated with your search. It's gonna have the bidding, it's gonna have a target, it's gonna have a language, it's gonna have a time, you name it. It's gonna have the ad exactly like the title, the description, the URL, and so on and so on. So this is what nobody tells you, but it's actually quite interesting. We Tiqets have venues all around the world. So you can imagine that we have, well, some accounts. We have them in different languages. So we have right now 12 languages, right? We have them, well, actually, officially we have them in 12 languages, but more than that. We are targeting many places. Yes? It depends. It depends because there are different types of accounts. But yeah, indeed, that's a very good question. Usually the accounts are at the level of, well, let's say that a country has different accounts. So a country is going to have different accounts. And then the attraction is going to be more at the level of the ad group. So what happens in the campaign is a little bit of magic of the marketeers, because they also choose, the campaign tells you where is your target region, what is your language, and so on and so on. But indeed, the Keukenhof is going to be here. And here is going to be all the keywords that are related to your search. Okay, so I thought, what can it be wrong? Right? I mean, it's simple, right? It's just this beautiful diagram, and it's simple. So because this is what I see all the time. I mean, for the developers and for me, this is what I see. I mean, I don't really look at the data, how the marketers do it. I actually make API calls, and then I fetch the data, and I can do my things, and I can visualize and blah blah blah. But this is my world. This is the world of the developers as well, but that's the world of the marketeers. The marketeers actually work with the UI, and there they do their magic, but the UI is actually quite sensitive. It's very easy to make a few mistakes, say. I mean, you can start working on something and then accidentally press save, and then, oh, things happen. Another thing is that it's very easy, right? Because when you call the API, you say, okay, give me the accounts or the campaigns or the ad groups with these IDs. It's a number, it's humongous, but it's a number. But over there, it's not a number, it's actually a name. So campaigns, accounts, ad groups have a name. So exactly relating to the entity that they are about. So I was thinking, but there should be a one-to-one relationship, right? This is not that difficult. No, it's not like that. So actually, as I said, when the marketeers are working in the UI, it's very easy to make mistakes. You can just change a little. You can put like an extra white space, and you don't even notice. So, as Sid said, like Tiqets started in 2014, and ever since then it has been growing. So now our data is actually quite complex. There are some mistakes in the data. There are some duplications in the data. So we actually have to clean it because we are building the foundations for the Burj Khalifa. So one of the things that we saw, remember, garbage in, garbage out. So actually our data has to be of good quality. And the thing that we are doing right now, well, actually we're about to finish, is there are some duplications. So we are actually gonna create campaigns automatically. So we have the system to create them. But if we don't clean our data, they're gonna be duplicated. So that's what we are doing right now. And I'm actually on time. So as I said, a country has different accounts, right? So we were thinking, how can we make this beautiful class in Python that helps us do the job, right? So we thought about it and we say, okay, a country has several accounts. The accounts have campaigns, ad groups, and so on. What do we need to do? So we need to do probably some pre-processing of the names, remember? Maybe we have to do some NLP. We have to duplicate entities. Maybe we have to rename. We have to do this. We have to do that. And then, exactly, we started the blueprint for our class. And now we can just apply it to the Netherlands, to Mexico, to Canada, to all the countries that we have. This is all I wanted to say. Questions? Questions? Everything was clear? Yes? Uh-huh. Yes, yes. Exactly. Exactly. Uh-huh.
Like object-oriented programming,
Uh-huh.
what were you using then? Just a script and just like load everything and every time you repeat it, or?
Exactly. So exactly. No, it's a very good question. It started just with a notebook because it was just very exploratory. We didn't know how bad our data was. It's actually not that bad, but exactly we didn't know. So we started just exploring, right? That's how you start your problems, exploring, making lots of graphs. In this case, we had to do lots of NLP and so on to process the data. And then we realized, okay, so we also need to have a marketeer in the loop. So because some of the knowledge is in the marketing department, so we also had to have a marketeer in the loop. So actually we created like a pipeline in which we do some steps. The time so 2 minutes. Okay, 2 minutes. Yeah, but indeed, so we had to make like a pipeline because we had to exactly do first exploration, export the results that are duplicated. We also need a marketeer to help us. Oh, this is the good one, this is the bad one, and so on and so on. But indeed, it's a very fortunately, I cannot give too many details, but it's a very good question. And indeed, we went to the level that we need a class for the country, and then the country has accounts and so on. So, okay, more questions? More questions? No. Okay.
Thank you.
Yes. Yeah. Oh, yeah. I have one there.
Before that.
Sorry.
Yeah.
Right in the moment. The problem, maybe it's just me that you went over the last slide very quickly.
Oh, sorry.
The problem was that you had different text data in the representation code and in the UI that marketers use. And
Yes.
you wanted to synchronize those.
Exactly.
You just have like single source of truth.
Yes, but exactly like, well, how our accounts are structured, before it was relatively easy to have duplication and you don't even notice because exactly, some venues actually change names. It's amazing, but some museums, today is Museum A and tomorrow is Museum A+1. So some venues, for example, change names. So these things you just get accumulated because we are a big company, so you just don't notice. So now it was the time to do like spring cleaning and then just get rid of it. But indeed,
Did you build like some measures of similarity using NLP, for example?
Yeah, exactly. Like we have to pre-process the data. Exactly. How you start matching these things? We use similarity. Yeah.
Cool. Give a big applause to Yuri.
Thank you.
We'll do a quick change for setting up the workshop. Moving the pizzas over there. I think there's still pizza left, so take some pizza. There's still salad left and drinks, of course, as well. We'll be back.
A class for it. That's actually the main purpose of object-oriented programming, so that you do not have to repeat yourself over and over. Is it good?
Yep.
Yay! Thank you, Data.
Sorry.
Thank you.
Thank you.
Yes. When do you use this in data science? Because when you just have a data frame, you can just apply it to your you can apply it to the whole data set at once, right?
Yes. First of all, this is not just a data science workshop.
Okay.
This is a Python workshop.
Yeah.
Who is a data scientist here or has used OOP in data science before? Okay. Can you explain real quick? Thank you.
Well, I think in any larger project, it is nice to have some inheritance applied to your code, right? It becomes more manageable, easy to repeat, becomes easy to understand, easy to learn what others do. So, yeah, I think it makes a lot of sense to use object-oriented programming principles in data science. But I think it's also interesting to look at it from a more generic coding viewpoint for one time and see how we can apply it to data science.
And it's, if I can add something, it is more modular. So while you develop your code, if you want to, for example, apply a different strategy or change something, then you don't need to change your own code. You can change also the parts that you want to change. You can create, for example, if you are connecting to database, you can create different functions, different classes connecting to, in order to use different ways to connect or something like this.
Do you understand? Okay. So today we're going to talk about multiple inheritance. Last time we talked about just inheritance. I'm going to read out what is there, then we get in the flow. Multiple inheritance is a feature of OOP in Python in which a class can inherit attributes and methods from more than one parent class. Remember when we had the first, when I talked about me and my daughter, I was the only person giving her like the methods, right? Like her eye and her nose and the mouth, remember? But now in multiple inheritance, you can have 3 different classes and one baby class is inheriting from those 3 different classes. Can you hear me?
Yeah.
Any questions? No questions?
When you say multiple inheritance, I can think of an example. It's like, again, come back to the employee. You can have a class like superclass, probably like the office location, superclass, department you're working, and a superclass of manager. So then the child class is the employee itself, right? So then you talk about multiple inheritance.
Yeah. So basically, if you hear multiple inheritance, just think about the fact that a class is inheriting from like more than one class, right? Think about your family, for instance. You do not just look like your mom. You do not just look like your dad. You also look like your grandma. You look like your grandfather. You look like, maybe there's a certain way you walk that looks like your uncle, for instance. You're inheriting that thing from your uncle and also inheriting some things from your mom and also from your dad. Is that good? Yeah, so today we're going to learn about multiple inheritance. We're also going to learn about method resolution order. We're going to learn about the drawbacks of the reasons why people don't like multiple inheritance. So this is a basic, this diagram is a basic example of what multiple inheritance looks like. So for instance, we have this child class. We have all this is inheriting from these 3, right? Do I have your attention, everyone? Yes. All these 3, this is inheriting from all these 3, and this is inheriting from these 2. So in the grand scheme of things, this is inheriting from all of this. Any questions? Any questions? Okay. Anyway, so this is a syntax. The syntax is you have the class, you have the body of the class, the base second class, and then this is the derived class. And you can see how we put the 2 of them together.
Shouldn't the arrows be the other way around? That's a little confusing.
I just took the diagram from the internet.
But basically, base gives it two child, right?
Yeah. This was the only good diagram I saw on the internet.
It's just the arrows that should
Yeah.
be the other way around. But it's the same.
We get it.
Yeah. Okay. So I have a basic example. I'm going to run it. I feel like, yeah.
What if two base classes like base 1.1 and base 1.2 have exactly the same method or exactly the same parameter?
Yeah, that is where we are going to go to. That has to do with the diamond problem. That has to do with it's also called the deadly diamond of death. Very scary. Yeah. So this first example, I'm going to run it. So there are different kinds of animals, right? There's the aquatic animals that live in the sea. We have the ones that live on land. And we have some other animals that live both on the sea and on the land. I felt this was a very good example for multiple inheritance. So this is, we understand, everyone knows how to initialize, right? Everyone understands what all the syntax means, right? Hi, do you? Do you understand?
Yeah. Me?
Yes.
Sort of. I mean, I'm not very big.
Okay, so this is just initializing the class, right? This is, how do I explain this? This is a string representation. This is just saying I am the name of the animal and I live in the sea. This is a method. Aquatic animals can swim, right? I am this and I can swim. So now I'm saying this is a whale, right? This. And I'm saying fish that swim. So I'm printing it and it's saying I am a whale and I live in the sea. It's a very basic class. It's okay to ask me questions.
Okay? I know you said how to explain this, but I understand the first one. The init is the constructor, right?
Something like a constructor.
Right. And then what about the second one? Is that like just a method that we can call, or?
No, it's just like whenever you instantiate an object, so if you don't use the REPR, I don't know how you pronounce it, whatever. Okay. So whenever you print that thing, it will print the object location instead of the text itself. So when you define the second function, so then it will print the predefined text here instead of the object location, if I'm right.
No, I'm just trying to figure out if it's just a method or
let me show you what that does.
All right.
So I have a fish and I print it. This is what it gives me.
Yeah, exactly.
So when I want to actually, you see that this looks like this.
Mm-hmm.
Do you see this?
Oh, I see it, yeah.
It's a string representation of what I would copy and paste to create a new instance of the class.
Okay.
That's literally what the repr is.
But does it have some functionality? Like what would, in a real life example, what would it give me? What if it's not there? Let me change the question.
Then you would get the object location, the pointer, where the memory location is, instead of printing at the text itself. Okay. Yeah.
Do you see?
It's good.
Do you see what I did? I commented out
We
what
get
it
the
looks like,
objects
so
from
you
the
see.
memory, yeah.
Do you see?
Okay.
You wanted to explain it?
Oh, but that's exactly what I wanted.
Yeah.
to say.
So if you have questions like this, you can always try it in your notebook. That's why everyone has the notebook too, so that you can always try it. And if you still don't understand, then you just ask.
All right.
Yeah. So let's move on. This is the fish. Now let's go to the terrestrial animals. I'm just going to print this. So a fish lives in the sea. This hippopotamus, right, lives on the land and it walks. And now we have the amphibians. The amphibians are animals that lives on the sea and also on the land, right? So you see that it's inheriting from the aquatic animals and it's inheriting from terrestrial animals. do you see how I'm inheriting? And a penguin is a very good example of this, right? So if I print this, a penguin can swim and a penguin can walk. Remember that if you inherit, you're also getting the, your mouth is open. Why? You have a question?
No.
Okay. Like her jaw was literally down. Okay. So because this penguin is an instance of this amphibian class, and this amphibian class is inheriting from aquatic and inheriting from terrestrial, I can get all the methods in the aquatic class and I can get all the methods in the terrestrial class. Okay, I'm going to ask questions since no one is asking me any questions and everyone is looking really confused. Okay, I think I saw a hand first.
In general, how deep does it go per class? Like how many inheritance can go?
Is left to you and your idea of how problematic you want to like have your code base, right? Some people it can be as deep as whatever, but for me, I would rather not have a very deep multiple inheritors because it can be really hard to track.
It kind of loses its meaning then.
Penguin is not an amphibian.
It's not.
No, it's a bird.
You just look it up.
Yeah, because you confuse me.
But it lives in the water, right?
But it's a bird.
Does it? It lives on the land, right?
It lives in the land.
And lives in the water too.
No.
I don't think it lives in the water.
Can someone Google this?
No, it's a bird for sure. I was a bit.
Does it live in the water,
You
guys?
want to give a workshop on this next time?
Yeah, maybe.
Can someone just just Google is a penguin an amphibian, please? Because now I feel like I cannot move on until I know this. Can you help me? It's a
I
penguin.
don't know how you googled it, but you're right. It's okay. It's like
It's an aves. Aves. That's
Did
bird.
you say it's a penguin and amphibian?
No, it's not.
So can you Google it?
Yeah. Here. Here, as you wish.
Okay, next question. Why she Googles it?
Yeah, I've just a question because I still don't get it. For example, like you say, you are a hyper walk, so the walk is actually assigned to something can walk, and why it returns you I'm a hippopotamus and I live on the land instead of return you hippopotamus can walk. So I'm not really getting this. Why is returning you? So it's returning you. I'm a hippopotamus and I live on the land. Why it doesn't return you? Only hippopotamus can walk.
Okay, let's do this.
Okay.
Do you see? This print hippo is returning this string representation.
Yes. Yeah, but why before was returning you? Because you printed hypo.
Yes. So if I do this, it's going to give me this one.
Why so? Let me see.
Because it's the string. You were my last class.
Yes,
I'm heartbroken.
Oh, I'm still there. I'm focused.
Yeah, ask me any question.
Yeah, sure.
Do you understand now?
Yeah, I understand because I was actually
It's the same thing that happened here. If I comment this out and I print this, it says whale can swim. That's literally this.
Okay.
Do you understand?
Yeah.
So you have three different things. So say if you instantiate the hippo and you just print hippo, and normally it should be having the string.
Yeah.
And because hippo.walk, you didn't print it out, so it doesn't do anything. Unless it say it's printing something. So when you say print hippo.walk, then I think it should get something out.
Yeah.
So you have to see what is after the hippo dot whatever they do. When it doesn't have the dot thingy, is when all these underscore thing could happen. You just have to play around with it. But when you dot and call a method that is inside the class, then you just go back to see define walk self, then it should return exactly what the things is returned there. So you just check, go back, okay, walk, okay, go back to that line. Nothing, okay, see what is the default one, kind of like go back and trace, then you will see. And if there's no print, it's return, it print nothing. You always have to print because return it somewhere until you print it. That will be shown on the screen.
Right.
Does it answer your question?
Yeah. It was my question, yes.
Characters, you know,
Is everything fine now?
Yeah.
Thank you. So yes, it's settled. A penguin is an amphibian, guys.
And they're cute.
Yeah.
But only according to this source, Beyond Penguins. I've never heard of it.
Beyond penguin?
Beyond Penguins
Frogs are
Sounds like some kinky
.ehe.osu.edu.
site. Okay.
That's
We'll get back to penguins
Okay.
later, but for now they are
Okay, let's go
amphibians,
back.
and yeah. So we get the basic syntax, right?
Yeah.
No more questions. Any questions from the back? You have any question? No. Okay. No questions from the back. So you understand if I wake you up in the middle of the night and I'm like, what is multiple inheritance? You're going to get it. Very good. You guys are very smart. Okay, so let's talk about the diamond problem. I'll read through real quick. The diamond problem is the term used to describe the ambiguity that arises when two classes, B and C, can you see B and C? When B and C inherit from a superclass A.
Wait, you mean when A inherits from B and C?
No.
When B, it's literally written in the notebook.
Yeah.
When B and C inherits from A,
Yeah.
right? And D inherits from B and C.
Okay.
So then it doesn't really know which one to call because then both B and C have the same attribute from A. So then it gets confused.
The arrows.
Yeah, no, it's actually
This is how you're going to see it in, because I checked for different.
No worries, trust me, no worries. No worries.
Yeah. So if B and C inherits from A and D inherits from B and C, if there is a method Y in A that B or C or even both of them has overriding, we did overriding stuff in the last notebook. Do you remember? You're shaking your head. You were not there.
I know what it is.
Yeah. Okay. So we're going to see an example of this to make it very easy. This is an example. I'm going to run it. I'll explain it first. So this is class A, right? And class A has this method called Y, and it's printing Y of A called, right? B inherits from A. Good. And it's saying Y of B called. You remember that if you inherit something from the parent, it takes the method from the parent, right? But now we are overriding it. We're saying, for instance, remember this amphibian. Let's say instead of calling this swim, we actually have another method underneath that says swim, but changes the return statement from the original swim. Did I lose anyone? No. Are you lost? Are you lost?
Me? No. I have a question actually.
Okay.
So can you go at the example below? Yeah. So when you name the method the same,
You're overriding it.
you're overriding it by default in Python?
Yes.
Okay.
so there is no.
What language do
hierarchy.
you come from so I can
C#.
actually...
Oh, you're sorry for me that I'm coming from C#.
Because I don't know how to explain. I don't know anything about C#. That's why I'm like, I'm sorry.
So there is no hierarchy. So the class A, which is on top, doesn't have a hierarchy over the subclasses.
What do you mean by hierarchy?
Like you can override just by rewriting it. So,
Yeah.
okay.
Java doesn't allow.
You'd have to write override.
So you can see we have B here. We read what the diamond problem is here, right? You can read it in your notebook so that you have a deeper understanding of what I'm trying to say. So we have the B class, and it's saying it's printing Y of B called, and we have C that also inherits from A. Remember the diagram? We have B that inherits from A. We have C that inherits from A, right? And then we have D that inherits from both the B and the C. Which do you think, if we call D.Y, which do you think is going to, what do you think is going to say? Just guess. Okay, this is what we're going to do.
I'm gonna go.
50% yes.
Yes. I'm going to take an answer from this table, from this table, from this table, and from the back. Right? Just guess. There's no stupid guess. What do you think on this table? That if we call d.y, what do you think is going to give us?
Y of B call.
Okay, is that what you all think?
Oh no, that's what my answer. I cannot represent it
Y of b?
because I
Okay, what do you think on this table? What do you think is going to say?
Yeah.
Is that?
Yeah, I think we do.
No, not I was asking that table.
No.
Oh, because
Just
it's-
guess. It's fine to guess.
But I'm actually curious.
Y of C on that table. Okay, Y on this table.
It doesn't have
Y of B. At the back.
because 8 is actually
Sorry.
Oh, sorry.
At the back, what do you think is going to call? Y of B. You all agree with him? You don't have to agree with him, by the way.
Ambiguity.
Okay, let's run it together. It says Y of B. And do you know why it says Y of B? Do you want to
because
try?
B is first.
Yes, because B is first. Let's try to put the C before the B and see what we are going to get. It says Y of C. Right? Question, yes?
Do you need to first have them inherited from class A? Because can't you just
You overwrote it already with the lower.
yeah? Because you can just name the method the same way. Doesn't that work the same?
Let's say, for instance, I am in your company and I created the A class and I left. And there are other people who have to inherit from this class. And then the penguin lady joins the company. She joins the company and she has to inherit from 2 different classes. But she doesn't know like that they were both, like the Y class, the Y method was overridden, right? And she decides to call hers. But she doesn't know like which one is going to be called first. And that's literally the diamond problem. Right? This is just me explaining in a very simple way what the diamond problem is. Any questions?
If you change the capital letter D to A, it will return you what is A called. Say, for example, you have like a small letter D equal to.
I want to initialize an object from A.
Oh, if you say if I
change to B, for example.
I say B is equal to
B, and return Y is not returning. Yeah, it's returning B and call, but it's B is inherited A, so Y does not.
Because it
return
has
to
its
Y.
own. It's overriding it. It has its own.
Oh, right. Yeah, okay.
Do you understand?
Yeah.
Great. So yeah, everyone understands what the diamond problem is, right? I feel like I'm not getting like a general yes. I'm just getting yes from this table.
Maybe it will be more clear how you would use it. If you have a class and you want the daughter inherit everything but one method, you override this method. For instance, right?
Sorry, what did you say?
If you have an old class and you want the daughter to inherit everything but one method, then you override that method without overwriting, like repeating the whole class. You have the same class with different methods.
I think you're trying to give an example, but I do not get it, kinda. But maybe we can move on.
Yes.
Yeah. So I'm going to move on, right? I get that we're doing mostly theory right now, but we'll get into good examples towards the end. So there is something called method resolution order, in which Python searches for the inherited methods, right? You remember when we did inheritance, or if you've used inheritance before, you remember using the super method, right? So what MRO, method resolution other, what it does is it tells Python where to look for the method, right? So I had to look for rules because most of the, hi, do you have any questions? Do you have any questions? No? Okay. No? Okay. I had to look for rules because I'm someone who likes rules, and I saw that some people said it's depth first. So meaning depth first means it looks, we're going to look at this example, right? It looks down first. It looks at, for instance here, it looks at C. We're inheriting from C, so it looks at C first. Then it's C inheriting from something. It looks at A. After it's done with A, it goes back to B. So that's depth first. How do I explain this better?
No, it's really clear. It's really straightforward. It's clear.
No, but you are the only person saying it's clear.
So
I need
basic-
everyone to
Oh,
say it's
okay.
clear.
So basically, you take the first class and you go up the tree until you reach
Yes, the
highest
end.
parent. Then you go to the B in our case, and then you go up against until you reach the highest
Yes,
parent.
exactly. So that's the rule for MRO, but it's depth first until that's not. Sometimes you actually look at the method resolution order for some multiple inherited classes, and you see that it's not actually depth first, and that's why I gave the second rule. It's depth first until classes are encountered which share a parent, then breadth first. Yeah, it's confusing. We're going to
For
see
classes,
examples.
for classes that share the same parent, right?
Then it's breadth first.
Then they just start cross-checking that what are the, okay.
So like this very simple example, we have the C, right? And then C shares with A, C inherits from A rather, and B also inherits from A. So it goes C, then it goes to B because it's breadth.
Yeah.
Breadth is this, depth is down.
Yeah, yeah.
Do you have a question? Yes. Okay. We're going to see an example. And the third rule is no secular relationships allowed. And I should also mention that no matter how much I explain this, you have to play around with the code for you to get a deeper understanding. Great?
Yeah.
Okay. So let's, together, we can run this. Now we want to get the MRO of the, what am I doing? Sorry. So let's see how it's actually, like the method, how it's resolving the method. So it starts with G because we're at G. This is the last class, right? So we have G. Are you guys following along? Yeah. So we have G, and then we have C. Do you see the C? That's the first one.
Yeah.
And you see that it doesn't go to E, it starts with A. And that's because, remember I said depth first?
So, to find the parents.
Does this make sense?
Yeah.
So it goes from C to A, right?
Yeah.
And then A is not inheriting from anything, so it goes,
Horizontal.
yes, so it goes to B. And that's why we have B as the next one here. So it goes to B and it says, does B have any parents? No, B is an orphan. Okay, no. Okay. Then it goes back to the next one, that's E. Since we're done with that depth, it goes to E. Then after E, does E inherit from anything? D, yes, perfect. So it goes to D. Does D inherit from anything? No. Okay. Then it goes to F, and that's the end. This, I doubt that anybody, in case you go to any company and they have classes this deep, maybe just pack your things and go. Just kidding. Just kidding, because this is recorded. Okay. Please stay at your jobs. Okay. But this is exactly how you can see it's not as simple as depth first. It's not as simple as breadth first. You can check some Stack Overflow questions and they say it's depth first, but it's not the truth, because if you play around with this and decide, okay, you want to create another example and have multiple classes inherit from each other, you will see that half the time, sometimes it's breadth, sometimes it's depth. But if you follow these rules I set out, depth first, until you see classes that share a similar parent, then it's breadth. Yes. So we are going to check out this example. I hope nobody has run it.
No, I haven't.
Have you run it? Say the truth, because I want to ask questions.
No, I was just paying attention.
Okay. Okay, so for this second example, what do you think is going to be the first class that we're going to look at? We're going to look at Z, because Z is the first one, right?
K1.
Then I'm going to ask.
Sorry.
The next one is what from this table? K1.
Continue.
Wait. I want to interact with everyone. Do you? Yes. I like how you're looking at me. What's the next one after K1? C? That's because K1 inherits from C, right? Can someone write down this flow we are? Okay, I'll just put it here. So we said Z, then we said K1, then we said C, right? Then from this table, what's going to be the next one? After C? No, I did not ask you. Sorry. That table. A, okay. So we said A, and that's because C inherits from A, right? So what's going to be the next on that table? Yes? You said B? Who said no?
No.
It's their table, so it's their question. You're sitting by yourself, but I have to ask you, what's going to be after B? No, we've done C, right? Can you help him on this table?
E.
What?
Whoa. We went to Z. Z inherits.
We are in B. After B is what?
I think it's E.
We are finished.
Hey, God.
K2. K2.
No, but you still have E. You see, the K1 is not finished. K1 inherit from C and E.
So which is the next?
B, and then you should come back down to E.
So it's E?
Because K1 is not finished.
No, you're not arguing with me. I'm just writing down.
Sorry. I was just trying
So
to...
it's E, right?
Well, in my opinion, it's not finished yet because you go back up and then finish, you come back down and you go horizontally.
Do you agree with her?
Yeah.
Okay, so E.
I don't know.
K2?
Yeah. K2? You agree? Okay. K2. Someone from this side of the back. I don't hear answers from this side. D. From this side. Is that B? Yeah. From this side of the table, if you divide into half, this other side. Yes. Looking at each other.
We already have E, so I assume to do is
Is that?
No, honey, you need an E.
Why?
E.
Do you want to help them? Yeah. No, we already have D. Yes.
Shouldn't the intersecting classes kind of influence the order?
Asking me? Or are you telling me to write down? So what is the answer?
I don't think it's the one that is on the board.
No, like after B is what?
I think we're wrong already.
Oh, you think everything is wrong? Okay, we'll just run it and see what the answer is. So we have Z, you are right, Z, then the K1, then C, then K2. Now let's look at it together, right? So we have Z, we have K1, we have C because K1 inherits from C, right? And we have K2. Why is that?
Yeah.
Yeah, why is it not A?
Because it says depth first until classes are encountered which share a parent, then breadth first over those.
One more time. Go back.
So we have C, right? C, of course, C inherits from A and B, but we also have classes here that inherit from A and B, right? So instead of it to go down that way, because it knows there are other classes that inherit from A and B, it goes to K2, the next one.
Okay.
Isn't it because E is common?
And this is why you are
E is the
careful
common
of
parent
implementing
between
something
K1
like
and
this.
K2?
E is common, B is common, A is also common,
So is it bad?
B is inherited here, and B is inherited here.
Okay, so is it safe to say that we should never implement something like this at work?
Yes. I'm explaining the, if you
Yeah,
hear
fair
anything
enough.
called the diamond problem, right? That's the reason why many people say never do multiple inheritance. But if you understand the method resolution order, if you understand, sorry, you want to say something?
No, I want to ask a question, but I will let you finish. I'm sorry.
Thank you. If you understand method resolution order, you can always do something like this .mro, or you can use this to get what exactly, how Python is going to read your methods, so that you do not get lost. Just in case you meet a legacy code, something that is already there, and you have no idea what's going to happen, you can always do this. I'm just using this to explain that, because some people will say it's depth first, but it is not depth first. It is not breadth first. There are dynamic rules to this. But never in your own work, in your own personal work, do something this deep. Please, I beg you, because you're going to cry. It's recorded. You're not going to cry. Okay. I put this very complicated example. I put this very complicated example so that you see why never to use something this deep. So maybe we just move on. In your spare time, play around with, try to move, maybe delete the C, put D here instead of C, play around with the method resolution order. Your question?
Yeah. My question actually is, I was actually really surprised that it evaluates first K1, K2, K3, everything before it decide which one to go to print. So it doesn't really make sense to me, because I thought that it would actually evaluate this class first, go up, because it's CC, right? And then E, and it doesn't know anything about K2 and K3 yet. And then it should go back down, but then apparently it evaluate K1, K2, K3 and see everything up, and then it start printing out things.
It evaluated K1 and they went to C before K2 and K3. And that's because of the secular relationships. That's because there are classes that inherit. There are so many things that inherit from A. There's one A here and there's another A here. There's another one that is B here, B here, E here, E here. So it's not going to just go up. It's going to go, okay, there's a C here. Okay, there's an A here, and the A, there's also another A somewhere, so we can actually leave it for now until we come back to it. No matter how much I explain this to you, you have to play around with it to like get a method to this madness. It's not madness.
It is, actually.
Okay. So we've used super before in inheritance. No. Any questions? No questions, okay. We've used super before inheritance. So super is used to avoid running into the diamond problem. You've used super before?
I've seen it, but it was a long time ago.
How do I explain super? I'll just run this example and maybe it makes sense to you.
Yeah.
So we have class A, and it's saying M of A called. We have class B, we have class C, and class D. Let's print out something. Is this self-explanatory, or do you want me to still explain? Any questions? Okay, I'm going to explain.
Why A is only called once? I'm just curious. Because they
we're
have
printing
B,
A just once.
because it inherited from B and C. So I actually thought that because it
A?
would go, because B and C inherited from A. So then I thought actually we'd just go up and print it twice from the superclass, no? Okay.
So remember when you asked me why it did not go from Z to K1 to C to A?
Mhm.
If it does that, it has to print A twice.
Yeah, that's was my question. Okay, it doesn't.
It doesn't.
Okay.
So here is a very simple example because it just says, okay, D is inheriting from B and C. B is inheriting from
Because
what
it's the
A,
same. Okay.
and C is inheriting from A. So it does D, it does B, it does C, and then goes to A.
Because they share the same parent.
Yes.
Yeah. Okay.
Time for questions? Okay.
And if you don't use super, it will print it twice, or not?
Do you want to try? No jokes. Try it.
Yeah?
Yeah.
Crash. No.
Okay. This is a very elaborate example, but I'm not going to do it right here because we need to move on. You can do it in your spare time because we have 2 other notebooks. So there's something called multi-level inheritance, and it's quite different from like multiple inheritance. And I felt I had to mention it here. Multi-level is, okay, this is the diagram, just so you understand better. Multiple inheritance is, you can see one is inheriting from more than one, but multi-level is class 1, class 2, class 3, straight line.
Mm-hmm.
Do you understand?
Yeah.
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 Do you get it? Do you get it? You get it? You get it? Get it? Okay. Question?
Diamond combines.
Is that
Diamond combines these two.
diamond is what?
The diamond
Problem?
combines these two.
Yeah, it's just a problem that we encounter in Python. It's not a type of inheritance. Do you have a question? Yeah, so this is, when you hear multiple inheritance, it's one class is inheriting from, forget the arrows, please. One class is inheriting from more than one, and the multi-level is, okay, this is class 3, but it's inheriting from 2, which inherits from 1. Right? So 1, yeah. This is a good example of multi-level inheritance. Let's quickly do the classwork, and then we can take a very short break. It's very simple. Thank you.
Thank you.
You have a question?
Yeah.
Yes.
Sorry, again, it's correct.
Yeah.
Correct. Why? So I'm trying to run an MRO method on a class D object out of the last example, and it says that the class object doesn't have the MRO method.
Class D?
Yes. If you go down a little bit. Yeah, the last one. Yeah, exactly. Where you call d.m. You call the method m of the D class, right?
Yeah.
So if you try to call MRO, d.mro, yeah, or like this, yeah. So should have the resolution. Okay.
I know what you're saying.
Just wondering if it's just me or not. Yeah.
And this is because of the super.
So if you use super, it just automatically not goes.
Super, I wrote here that super helps you avoid running into diamond problem. Originally, like Python uses MRO to decide what the order in which your classes should be inherited, right? But super helps you do like a lot of this. So that's why this doesn't work. And that's why I showed you this without super before showing the super. Thank you for running that and sharing it.
So just to follow up on this super.
Can we start the classwork while I answer questions? And if you have any questions, Alona and Demi are here to help. So don't just point to me.
For the super.
Is it there? Yeah. Let's look at the solution together so we can. Thank you, DJ.
Doesn't want to. It brings the correct order.
Let's look at the solution together. And
it doesn't bring the.
there is. My people used to say, or my people say, there is no one way to do markets. You can always go through, go with the tram, or go with the bus, or go with the metro. So my solution is not the best, it's just a solution. Yeah.
Just go and check solution. I don't like when solutions are available.
Okay. I'm sure we all did this. Maybe more fancy than mine. But I wanted y'all to understand MRO, understand class structure, and that was why I asked us to have this expected output. Hi. Hi. And this was my solution. So we have the person, and it prints out I'm a person, obviously. And father inherits from person because father is a person. And it says I am a person because it inherits from this. It says I am a person and cool daddy. That's wrong. And a cool daddy. Okay. And then mother is a person and it says I am a person and awesome mom. And the child inherits from the father and from the mother, but I'm overwriting it and I'm saying I'm not inheriting what the string. I'm not doing this. I'm just saying I'm the coolest kid. So let's do this together. I'm not going to run that. I'm going to run the person first. So it says I'm a person, right? And then the dad. I'm a person and cool dad. And cool daddy is still good and a cool daddy. Okay. Then let's run the mom. I am a person and an awesome mom. Not a awesome mom. Sorry. Yes. And then the child. I'm the coolest kid. Questions?
Why hard-coded the personality?
Why hard-code the personality?
Yeah, so can we make personality dynamic?
What
So the coolest, awesome, cool.
Oh, that is the expected output. I just need people to know how to inherit and return something that is not exactly what you're inheriting. That was all I wanted to do.
Well, we just was wondering how to do that.
Oh, okay. I'm just, I mean, what I'm expecting is I just need a string, so there is no fancy, I mean, if you did something fancy, that's fine, but I wasn't expecting something really fancy. I just wanted you to inherit this string method, right? This, and then add something to it. Questions? Great. I'm looking around for people who look
No,
confused.
I must tell you that I overthought. I thought that, you know, the order has to be like this, and then you have to find some magical methods or ways to actually print the other way around.
Yeah.
So I was just trying to Google the how outlet. I couldn't find a
What
way.
were you Googling?
How? So you run the object with the MRO like this, with the going down, but then somehow when you instantiate it, it should print everything the opposite order.
But the expected output says I am a person first, then cool daddy, then awesome mom, then.
Yeah, so I thought there's one way I can reverse the printing everything somehow. I overthink. That's the
No. But how you learn is actually by like not just doing what the person says you should do. You should also try to like see, like she says, try to print it in the opposite order. Because how else would you learn if you don't try?
And I also have a solution, which is that you just print "I am the coolest kid" in the person, and then the further you the other way around, which is dumb. But yeah, anyway.
Who else attempted this? Not exactly this, but who did the classwork? Yeah, I saw your work. But I saw a lot of people's work, and it was almost perfect. I'm saying almost perfect. Even mine is not perfect. Right. So we have how many minutes? 5 minutes? Because I said 5 minutes. We have 10 minutes. Okay. So we can't actually go through all the notebook.
Sure.
In your spare time, look at composition. I'm going to just quickly tell you guys what composition is so that when you look at the notebook, it's pretty easy. Composition takes you way away from what inheritance and multiple inheritance has been saying all the while, right? Composition is, people are like, why are we trying to predict the future by using inheritance? Why can't we say, okay, this is a person, this person is made up of a head. Oh, that's not a good example. Give me a minute.
Can you do like a cake?
Employee.
Oh, okay.
Full-time employee, part-time employee.
No, that's not the example.
Okay. Go.
So, say for instance, you have an employee. This employee has an address. This employee has a salary. This employee has different things that makes up this employee, right? So why are we trying to do all this inheriting from this, inherit from this? Why can't we have them separately? Just like, imagine composition, something makes up, so many things make up one person. That's literally what composition is. Composition is saying, let's not use inheritance, because if you're inheriting, you're going to be inheriting things you don't need, right? Why can't we have composites, components? Who does JavaScript here? Do you use any framework? Okay. So I do Vue, right? And in Vue, you have like components that make up one particular page or one particular component. So instead of you to have, so for instance, let's say in this person class, we have something that a father has that a mother does not have. And then a child has to inherit all of these things that we do not need. Right? That's exactly what composition is. And it would be really lovely if we went into it, because it's super cool and many people do not know about it, but you have it in your notebook. It would be really lovely if you take a look at it, and you do not even have the problems of MRO with composition, because you only put in what you need. You do not take things you don't exactly. And it doesn't go that deep, right? So I'm creating an employee class. I need an address. Okay, I take the address class and I put it in. I am creating a song. The song needs an album. I don't know how that works, but it needs an album. It needs a title. It needs maybe a band. I don't know. The example is very fuzzy, but you get what I mean, right? that's exactly what composition is. You can take some time out to look at the notebook. Is that what you guys are looking at?
Mm-hmm.
Okay, great. The last notebook is supposed to be about data classes, which is super cool. When I found out about data classes, I couldn't wait to use it. I wanted to just plug it into our code base, and my teammate was like, hold on, don't do that. Right? Because data classes, you don't have to start doing init, you don't have to do the wrapper that we talked about. We don't have to do all of those things. It's just like a code generator, right? You see how excited I am? Because it makes my life easy. Data classes, you just use a data class decorator and it creates all those things for you under the hood. How awesome is that, right? So if you have any questions whatsoever about composition, about multiple inheritance, even the questions you think you could not ask today about data classes, you can always ask these two lovely women.
Maybe we can do one fast example from bulletin. Really fast to show.
I still have energy to do this. Yeah, do it out the back. Yeah.
Just really fast. Like
yeah, then just
5
show.
minutes each. Show where you're so excited about.
Okay. Composition. Quick example. Okay, let's look at this quick example. Quick. So what inheritance does is, like, this is inheritance here. Like, you inherit from this. But composition is, we don't have to inherit, right? A bus has an engine. I think I wrote something really simple here. Inheritance models is a relationship. A mother is a person. While composition has a, right? So you say a bus has an engine, right? And many people say use inheritance, don't use composition. Many people say use composition, not inheritance. But for me, personally, I think there are situations where you need to use inheritance instead of composition. And there are situations where you need to use composition instead of it. There are many cases where you need to use composition instead of inheritance.
Can I ask a question? So
Is
when
questions
you...
allowed? Okay. Yes. Ask me real quick.
Okay, so when you use the composition, self.engine equals to engine bracket. So when you want to call a method, so then you have to write dot engine dot because so then you have to do, because you instantiate another class,
Should
right?
we just look at the quick example because I don't get what is. Okay, so if you look at the notebook, I actually wrote out advantages and disadvantages of all these
Yeah,
things.
okay, that's exactly what I was asking. Okay,
But look at this code example. I'm not going to run it. This is a song, right? This is a song, and then we have an album. We have an artist. But you see that the album itself has a song. Album needs songs, right? It's not going to be an album if it doesn't have songs. So we have songs. This is composition. We're just plugging the song into the album class. And then for the artist needs albums and they need songs, right? So we have song and we have album. We're just plugging it in. The playlist needs song. Is this more confusing?
Yeah. Yes.
Okay, scrap the example. But you get the overall picture, right?
Yeah.
Of a composition. Yeah. If you run it and you have any questions, I promise you, these awesome women are here to, I feel like I'm excluding myself, but they are here to answer your questions, and I'm also here to answer your questions. Let's quickly look at...
Can you give an example when you use composition and when inheritance?
Okay. Let's look at the solution to the classwork I gave. I gave use composition to design a developer class. Real quick. Sorry. So here I created an address, right? This is me creating a developer class. So a developer has an address, has a manager, and this is the developer. So, you said? Sorry?
No, go on, sorry.
Okay, I'm just going to
reading out loud.
This is the manager, and this is the developer.
Shouldn't they inherit over there?
Shouldn't what?
Self.manager, shouldn't it be like if we are using Composite to be manager there?
Sorry,
Which line we're talking about?
What line are you talking about?
At self.manager for the developer. So you have self.manager equals none, right? That line.
Yeah.
Yeah. Like Composite shouldn't.
Yeah,
Can we
then
use it here? Like for example,
Then you would
self.manager to be.
So you see here that I have manager 1. I have the address, right?
Yeah.
Okay, let's start from here. This is the address. You understand how all of this works, right? It's just init and the string.
Yeah.
And here, the manager also needs an address, right?
Then may I
See that I say like self.address is equal to address?
Yeah, may I pause here? Why don't you here use self.address equals to capital letter address bracket instead? Because that's the composition one, right?
But that's what we're doing here. We're saying manager 1 is equal to dot address is equal to this address, this one.
Oh, she's just passing an entire.
I'm just passing the instance instead of the actual class.
Oh, okay. Because the example we did in the workshop, in the previous.
That's in here. I said leave everything you know.
Oh,
about
okay.
it.
Okay. Sorry. Okay. Yeah. Okay.
Yeah. So if you actually print manager 1, so you see that the address we had, the first one, I copied this address from Google. That's the exact one we have here. So now we don't have to say inherit from this or inherit from that, right? You see that manager 1's address is the first address we had here. Great?
Great.
Yeah.
So many questions. Okay, then let's look at the developer. So I want to assign a manager to the developer. I want to assign, we have 2 managers, remember? Right? I want to assign a manager to the developer, and I'm saying developer 1, assign manager, manager 1.
Yeah.
So if you print out the developer, it says Jane Doe, that's the developer here. She's in customer service department, right? That's customer service, and is managed by Samantha Joseph. So if I decide, like, okay, I want to assign manager 2, there is no manager.
Okay.
There is no manager because of this method here. Is it more confusing or less confusing?
Why? No.
Do you understand?
I think I can give an example.
Yes,
So imagine you are building the system. So HR people comes to say, we need the system to calculate salary. And you have like, you do traditional inheritance. You have, I build a class person, person has ID, person has address, person has all of this stuff. And then I say we have, from person, we have manager and developer. So I build a class manager that inherits from person. I build a class manager that inherits from person. It inherits all address, ID, all this stuff. Okay, then next I say, they are both like full-time people. They work full-time. So I create, say, okay, I need to create a class full-time. Okay, what to do? So I go back. So this is my class person. I create a class full-time person. I inherit from person. I created a class part-time person, inherit from person, and then I go, okay, I have a manager. Manager is a full-time. I inherit from full-time. I have a developer. Developer works remotely. Okay, I inherit from, let's say, this part-time. So this is how inheritance works. But just imagine you have a person who is a manager and who works 1 week, it works full-time, and other weeks it works like half-time. Okay, say, okay, I will do, let's say, once again, I will inherit part from this, and then it goes more and more and more. It is more confusion and more confusion and more confusion. And you will never find a way out of it. That's your development hell. And then say, okay, what do we need? So we need to system, we need to say, okay, let's do composition instead of inheritance. So we have a base class employee, for example, and then what do we need for employee? We need to understand like how this person will work full-time or part-time. We need employer ID, we need, let's say, to define, would we have like manager, like a type of the employee, and then we say, okay, we build completely apart class, separate class. This separate class will have address. We build separate class, it doesn't inherit from anything. This is a class like, let's say, full-time salary. And then we just take these parts, and when we need it, we plug it in our code. So it's much more easier.
But you plug it to a property, not to the actual class, right? That's the whole trick.
Yeah, exactly. To the instance itself, right?
Yes.
Okay. Okay. Yeah,
So,
that's clear.
Composition, people make the argument that composition is longer to write, and it's true. But the truth is it can get very complicated with inheritance. For instance, you have somebody comes and creates something for you, right, in your code base, and the person leaves. And then 16 people have to inherit from the same class. If I'm working on the parent class and I change something, everything is going to break. You understand? But with composition, you know what you are taking from, where you are putting it in. And that's why people love composition over inheritance.
So is it also easy to make changes on multiple, like really a lot of data points then? Because, you know, like this makes sense for me if you only have 3 employees who want to plug in, play around. But if you have like so many employees and you want to play around with plugging in, plugging out, is it easy to do with composition or not really?
Easier.
Easier?
Yeah, because if you say that I need to change this, and if, for example, I need to change address, and if you broke everything. If it's all multi-inheritance, you broke everything. And if it's composition, I just change a small change here, and that's it. Let's go.
In her case, she had a method. You just changed that method.
So say 20 employees become part-time from full-time, 30 employees from part-time to full-time. How do you change it? Then you have to go to every single instance to update it, right?
Yeah, but then how would you do it?
Let's do that.
Okay.
Sorry. Okay.
So I'm going to show data classes real quick, and you see why I love it.
Oh yeah.
This is a regular class. So we have, of course, you know what a regular class is, right?
Mm-hmm. Yeah.
So this is, it's just an article class, and it has a wrapper, blah 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 blah, and it just says how to create this from this. But this is a data class, and see how short it is, guys. Look at how short it is. And then when I run it, and I run,
You look so happy.
yes, I am.
Nice. The first smile.
A lot of time.
And I run this, you literally see how easy it is.
Yeah, true.
You see how easy?
Yeah.
Like, look at how short this code is from here until here. And look at all of this from here until this.
Everything is automatically generated.
No,
Yes, it's a code generator. Right? But you don't have to use it. I'm just showing you super cool stuff. Yeah. I think that should be the end. I mean, you can always take a look at the notebook for data classes, but I think that should be the end of this workshop. If you have any more questions, maybe after the workshop or on the Slack channel. Yes.
Can you scroll to super cool stuff once again?
You have it there. Yeah, it's true.
Okay, everybody, give a big hand for our workshop presenter. You want to take a picture?